we talked about the evaporative cooling effect with water and how meteorologists can use that using two thermometers to estimate what the relative humidity of air is at a given temperature. We can show something much more dramatic and replicate what Benjamin Franklin did over 250 years ago. So we're going to use four substances. Here we'll have, again, water. Here we'll have something a little bit more volatile, which is ethanol. Here we'll have a third substance that's even more volatile, what's known as pentane. And then this fourth one right here is extremely volatile. This is diethyl ether. It stands to reason that the more volatile a liquid, the quicker it evaporates into the air, so therefore the more energy it will carry away. And this is what Benjamin Franklin discovered in an experiment in 1758. So what we have here are some devices. Let me show you a panoramic view or a large scale view. Those rectangular little boxes are what are called a lab quest, and they're basically going to measure some data for us. And attached to them is a temperature probe. And so for this one right here, the temperature probe is the stainless steel rod coming out of that black plug, and you'll notice that it's wrapped with a small piece of filter paper and secured to the probe with a small rubber band. And it's hooked up to this device, and you can see that it's recording temperature. And the temperature for that probe is 21.5 degrees. I have three similar setups here. Again, there's the probe with the filter paper attached with the rubber band. The temperature it's recording right now is 21.5 degrees Celsius. I've got a third one right here, 21.9 degrees Celsius, and I have a fourth one right here, which is 21.6 degrees Celsius. So the temperatures are not all exactly the same, but you can see that they vary by just a small amount. So 21.6, 21.9, 21.6, and 21.6. Now what I'm going to do is I'll just, one at a time, starting with water, is I'll dip that filter paper into the device, and then as it evaporates, we'll see, right here, we'll see how the temperature changes. Okay, so we've already done this with water. We saw that the temperature change was not much. If the relative humidity is quite high, that means the air is already storing a lot of water vapor. So I'll simply take the probe off. Right here, there's the filter paper. I'll simply immerse it in the water. Get it nice and wet. And then just bring it out here. I'll tape it to the table and just expose it to the air, and then we can just watch the temperature drop. Now remember, for the sling psychrometer, water's not that volatile. Looks like we're getting some interference from the lights. There we are. You can see the temperature is slowly dropping. So it went from about 21.6, it's now below 20, 19.6 degrees Celsius, and so forth. But again, water's not that volatile, but you know that even on a cold day, if you leave some water out on a table, it will slowly evaporate. And we talked about the difference between evaporation and boiling. Okay, so we got a temperature change there of a couple degrees Celsius. And what you'll notice is that, again, we saw that the relative humidity in the room here was quite high. So the temperature will continue to drop, but at an ever-decreasing rate. And eventually they will reach a point where there won't be any apparent change in the temperature because the amount of water that's evaporating into the gas phase is so small that it's not carrying away much thermal energy. Okay, so that's for water. So let's say about 17 degrees. So for the second one, I'm going to use, instead of water, I'm going to use ethanol. So again, let me unscrew this. I'll take the probe. Again, we're starting at about 22.9. Looks like the temperature has gone up slightly. There's the probe with the paper on the filter paper on the end. I'll simply immerse it and pull it back out. Again, expose it to the air, and then we'll simply watch the temperature. Okay, now what you notice is it's decreasing just like for water, but it's decreasing at a relatively fast rate. We're already down to about 19 degrees Celsius. If I go over here to the water, it's still dropping. It's down to about 15.9 degrees Celsius. And for ethanol, you see that it's still dropping fairly quickly. and it's going to catch up to water and pass it right about now. And again, you know, if you've ever dealt with ethanol, it's a relatively volatile substance. So it evaporates much faster, and so therefore it carries away more calories per second or per minute than water would. Sorry, I'm getting some interference from the ceiling lights here. So we're down to about 14 degrees Celsius. If I go back over here to water, you can see it's 15.6, and it looks like it's pretty stable at that point. So we got temperature drop there, but here we got a more significant temperature drop, and it's still dropping. Okay, so pentane, that's what we'll put on our third probe. Pentane is even more volatile. Pull this off. I'll pull the probe off. Again, the starting temperature for pentane, that probe is going to be 23.7 degrees Celsius. I'll dip it in, tape it down, push it back just a little bit. There. I didn't touch the metal part of the probe, and you can see it's dropping rapidly. Look at how fast that temperature drops. So that tells us that pentane is extremely volatile, and so as it evaporates, it cools the surroundings, and so now it's dropping down to below 7 degrees Celsius. Okay, and then the fourth one here will be ether. I have to do this quick with ether because it's so volatile, and it's also somewhat toxic, so we don't want to be breathing a lot of it in. The starting temperature for this probe will be 23.9 degrees Celsius. So I'll bring it over here, immerse it, bring it out, and look at how quickly the temperature drops. In fact, I can smell the ether. It has a distinctive smell because it's so volatile. Within less than 10 seconds, it's dropped a significant amount. And this was the experiment that Benjamin Franklin and one of his colleagues did, taking ether and simply immersing a bulb, a thermometer bulb in it, and getting a significant temperature change. I think the numbers I gave you were the starting temperature was 61 degrees Fahrenheit or something like that, and they were able to drop it down to almost 0 degrees Fahrenheit. So a significant drop. So this just as a more dramatic example of evaporative cooling.